All right, so let's do a little bit of modeling of actual expressions. So I'm going to be working off of page 2 in your Algeblocks activities packet. And I'll mostly have, when I'm modeling, I'll be using the this particular environment. And then I will flip over back to Notability the way we do in class to actually make the drawings of the particular blocks. So, question A. So 1A. Just A. Question A is to model 1. Well, we know that to model 1, we need to look at this block. Right, that represents 1. And now we have a mat here in front of us that seems to have a plus and a minus next to it. Now, you can use it vertically or horizontally, it doesn't really matter, but the shaded region represents a negative and the non-shaded region represents a positive. So if we're trying to model 1, the implication is that we need to model a positive 1. So let's model a positive 1, and that will show up here. Now, what if we were to model 6? So let's model B. That's 6. So that's positive 6. So still, we would want to have, oops. There we go. So we would have 2, 3, 4, 5, and 6. All right, and again, we're assuming that this is going to be positive 6. So that models 6 on the positive side, so that's positive 6. Now, for question C, it's actually asking us to model negative 4. Well, how do we model negative 4 if not to take 4 of these guys and move them to, let's start another one. The left side. These, on the other hand, we're not going to be using. There we go. So that models negative 4. So let's take a look at going to our page 2 in the Algeblocks handout and seeing if we can draw some of these expressions. So our green square was 1, positive 1, if it was in the positive. If we had 6 green squares in the positive, that would have modeled positive 6. And if we wanted negative 4, we would have to put 4 squares in the negative. But this question actually asks us to model positive 1 in another way. Now pause this video and see if you can figure out a way that you could model a positive 1 in yet a different way. So if you had an idea, that's great. The way that Algeblocks is built is that it allows you to use an idea, a concept like zero pair, to model 0, to change the look of the mat, but not to change its value. So this is actually going to be a 0 pair. And why is it a 0 pair? Well, it is a plus 1 and a negative 1. And the total value of that is 0, because plus 1 plus a negative 1 equals 0. And we know that. So the value of the mat, of the second mat, is actually still 1, but it looks substantially different from the value, from the way that the first mat looks. And as long as we have the value of the mat as 1, we could actually add a whole bunch of other things to the mat if we really want to, as long as we're making them 0 pairs. And you notice that all of this is actually paired up. So it is a 0 pair and does not change the value of the mat. So you can go ahead and try to create different looking mats for the 6 and the -4. And I'll just do one for -4 and I'll leave the rest of them to you to do. So this is my -4. And I would like to create some 0 pairs on either side. And maybe that. And maybe this. Anything you want, as long as everything that you've added, its total value is 0. So next, what it's asking us to do on the next page is it's asking us to try to model expressions that actually contain variables. So x and -4c squared. So let's get back to our keynote, and we need to, for D, model x, and for E, model -4c squared. So let's do D first. So x, well, we would need to know what we're going to be calling x. That's something that we would need to define. Well, let's say that I would like to call the orange a 1 by x. So my oranges will be x, and this will be x squared. I don't know what the other variable would be, so it doesn't really matter. I don't have to define it at this point. So then, that'd be -x. This would be positive x. Okay, so that would be a picture of positive x, a model of positive x. Now, for question E, we would need to define the variable c. So let me get rid of this for new definition of variables for new question. Now, c, I feel like calling this c. This would be c squared. I don't know what the other variable would be. There's only one variable in the expression, so I'm going to keep it at that. So I have -4c squared. There are different parts to this particular expression. The c squared tells me what kind of type of block I'm going to be using. Now, when I say -4c squared, the 4 tells me how many number of blocks. All right, so I know that this particular expression is going to require 4 of the c squareds, and those are the yellow squares. And the negative tells me where to put them. So let's see how this plays out. Now, if I need 4 c squareds, and I need to put them in the negative. There's 1, there's 2, there's 3, there's 4. So I have 4 c squareds in the negative. Let's go back to drawing these. So if you remember, I'm just going to switch to a neutral color here so that I don't have to color code. I'll just be able to describe them by size. So if I want x, my x can be a rod, any rod that is positive x. Now -4c squared, -4c squared, this means it's going to be a square. This means there will be 4 of them. right? Let me actually write number, and this means where. So where is in the negative. So there will be 4 squares in the negative. Well, how do we model 0? Nothing. That would be one of the ways to model 0. But remember, as before, we need to use we could use our 0 pairs to make the mat look differently, but still have the same value. So for example, if this is my x, it's a positive x and there's only one of them, then I could add some 0 pairs. And maybe one of these, maybe one of these, as long as what I'm doing is actually a 0. Whatever I'm adding actually is a 0 pair. And I'll let you do the rest of the alternative models for x and negative 4x squared. For 0, it's similar to that. As long as I'm drawing 0 pairs, it's all good. So then all of that is a 0 pair. So the value of the whole mat is 0. Now, let's look at these questions. Write 6 statements that are equivalent to x squared in algebraic notation. So x squared is certainly one of them. But then, remember that we can make x squared on the mat look very different. We can make x squared look like x plus 1 minus 1, because this is a 0 pair. Or we can make it look like x squared plus 3x minus 3x. This is a 0 pair. Or we can go really crazy. We have 0 pair, 0 pair. You can come up with many others for number 5 and 6, but you get the idea. Now, let's do a couple more examples. And I'm not going to model them with the Algeblocks. I'm just going to draw them here. So, let's take a look at 3y minus 4. So we have a 3y and a negative 4. So we need the y's. This is the type. This is the number. And it implies that it's positive. This is the type. This is the type. That's the number. And this is location. So for 3y, let's pick a y. It's positive. If this is our y block, then we need 3 of them. Remember, the fact that it's 3y just means that it's got to be a rod that is a length y. And you might, in the manipulatives, you might choose either a yellow or an orange rod. When you're drawing it, you just need to make sure that you're drawing rods of about the same size, which makes me think that I should probably redraw that one. All right. And minus 4, well, the type is that these we're counting units, so these are going to be our little green squares, and there are going to be 4 of them, and they'll be on the minus location. I'm going to leave the B to you. Let's try C. So we have negative 3q and negative 4. So everything is going to be on the left-hand side. A q, let's say it's going to be our yellow rod. And I have 3 of them, and they're all on the negative. And then the negative 4. So that would be the model for our negative 3q minus 4. Let's take a look at what's happening here. Let's try E together. I'll leave D for you, but let's try E together. So we have a negative 2p squared plus 2p and a minus 3. So this is the type, this is the number, and this is the location. So we need two p squareds on the negative side. Now p squareds would look like squares. So we can say that that's going to be our p squared. If that's our p squared, then a rod of that same length size is going to be our p. And then single units are our singles. So we need two of the p squareds in the negative. And we need two of the p's in the positive. And we need three singles in the negative. That would be representing negative 2p squared. So let me highlight them as I go. Negative 2p squared plus 2p minus 3. Now, in a situation where we have two variables, it's still up to us to define what those variables are. So let's say I'm going to make the longer rod r and the shorter rod t. It's up to me which ones, or up to you, which of the variables will be represented by which of the blocks, as long as that you make it clear which one is which. Now, we need 5 r's and we need 2 t's, and they're all on the positive side. So we'll have 5 of the longer rods and we'll have 2 of the shorter rods. All right. So, and again, forgive my inconsistency in size, but that's what generally you can see that these are the longer rods, those are the 5 r's, and these are the 2 t's. So what I would like you to do is then be able to represent the expressions that are actually given to you on these mats in algebraic form. Now notice that you're given the meaning of each of the blocks. So that's defined, we don't have a choice. But you need to write the algebraic form of those expressions. So let's just do one as an example. Well, the ones on the left are going to be negative, and there are 4 of them, and they are units. They're just ones. The ones on the right are going to be positive. There are 2 rods, and those are of the b kind, and there's 1 square, and that's a b squared. So that is an expression that represents the mat. Does it have to be written in any particular order? Not to be accurate. Sometimes some people like to write it in the order of decreasing power, but that again is just convention and it's just being pretty. But mathematically, there's no reason to write it in one particular order over another. Now, for these particular examples, not only are we asked to actually write the algebraic form of the original expression, but also to underline the 0 pairs. Now you see that there's 0 pairs in from the picture. There's a 0 pair. There's a 0 pair. We have a 0 pair here. We have a 0 pair there. We have a whole bunch of 0 pairs in these particular examples. So we should be able to identify where those 0 pairs are. So let's see if we can write these expressions in algebraic form. So the way that they are actually represented is that we have -4 and a -r squared on the left-hand side, and we have +2 and +2r squared on the right-hand side. Now, knowing what's happening is we know that we have the -4 and the +2. Now, 2 of those are actually 0 pair. So 2 of these on each side is a 0 pair. So we can simplify that to leave -2. Because the rest is 0. The value of the rest is 0. Now for the r squared, we know that we have a -r squared on the left and 2 +r squareds on the right. We know one of those is a 0 pair. So we can simplify it to plus r squared. Now I'd like you to pause this video and complete the B, C, and D on this particular page. So once you've completed, we're going to do D together. And let me just remind myself, R and S. So if we actually write out the expression that's modeled here, we have 2r squareds on the negative side, 2r's on the negative side, and 3 on the negative side. And then we have 3r's on the positive side, 1 on the positive side, and an s squared on the positive side. So let's see if we can find some of these zero pairs. Well, I see on the mat a zero pair here. I have 2 on the negative, 2r's on the negative side, and 3r's on the positive side. You see them right in here. So there's 2r's on the negative side and 3r's on the positive side. 2 of those will be zero pairs. So I can actually rewrite the negative 2r and plus 3r as plus r because the rest of them make up a zero pair. Now for the singles, I have a negative 3 and a 1. Now there is a zero pair in there. If I do not write that zero pair, I can simplify it to minus 2 and plus s squared. So that'll be the simplification. Notice that there's no conversation about like terms here. There's no need for a conversation about like terms because it is clear to the students that the zero pairs can be made up of the same blocks on both sides of the on the positive and the negative side, balancing out or being equivalent. So the conversation, the process of actually simplifying is just removal of zero pairs. What we're going to do next is we're going to look at the operations in the model of Algeblocks. So we'll start with addition.